bymnCoachingcentre. So today I'm going to explain your 12th standard chemistry first chapter solid state part 2. So last today I explained till the coordinate number makes three-dimensional packing of constituent particles. So AB or arranged as AB or arrangement gives hexagonal closed packing. It is like hexagonal. And ABC or arrangement gives cubic also packing face or face centered cubic packing. It is like cube they are saying. And next is the tetrahedral voids or holes or voids surrounded by four spheres present at the corner of a tetrahedron. Coordinate number of tetrahedron is 4. So here 4 tetrahedron means 4 here, 4 here also 4 like this. And octahedral voids, the holes surrounded by 6 spheres located on regular tetrahedrons. Coordinate number of octahedral void is 6. So 6 here, see 6 are there. And like that. Density of unit cell. So density of unit cell is equal to mass of unit cell by volume of unit cell. So here D is equal to Z into M by A cube is equal to Zm A cube into Na. So M is the molecular weight, Z is the number of atoms per unit cell, and N is the Avogadro number, and A is the edge length of the unit cell. The structure of ionic crystal, here you can see the ionic ratio of cation and anion play a very important role in giving a clue to the nature of the crystal structure of ionic substance. Next is structure of ionic crystals like this. So NaCl, all octanol voids, and CaCl, that is calcium chloride, that is for body center, there will be cation, and ion will be simple cubic, it is like cubic. And next is ZnS, that have alternate tetrahedrons and unit cell it has, and fluoride structure, alternate body center, and simple cubic unit cell. And Na2 all tetrahedral states and unit cell it has. So imperfection in solid. So in a crystalline solid, the atoms, ions, and molecules are arranged in definite repeating pattern, but some defects may occur in the pattern. Derivation from perfect arrangement may occur due to rapid cooling or presence of additional particles. There may be changes, and the defects are two types. They may be namely point and line point. Sorry, namely they are point defect and line defect. So point defect are irregularities or deviations from ideal arrangement, and point defect are of three types, that are psychometric defects, impurity defects, non-stoichiometric defects. So these are the point defects that do not disturb the stoichiometric of the solid. They are also called as thermodynamic defects. So here is stoichiometric defect and Franklin defect. So Franklin and stoichiometric, there are two types in stoichiometric defect. So Franklin, it is due to the equal number of cation and ion missing from the lattice site, and Franklin defect, it is due to the missing of ions from the lattice side, and this results in the decrease of density of crystal, and and in the Franklin it has no effects of density of the crystal. And in schizoaffective, this type of defect is found in highly ionic. It is found in highly ionic, and this type of defect is found in crystal. They are found in highly ionic. They are found in crystal. So next, second is impurity defect. So it arises when foreign atoms or ions also present in the lattice, if it is lattice, and Impurity defects can also be introduced by adding impurity ions having different charges. So if the ions that have different charges, if it joins to atom, then it is called as impurity defect also. Next is non-stoichiometric defect. Non-stoichiometric defect crystals are those which do not obey the law of constant properties. The number of positive and negative ions present in such compounds are different from those than their expected chemical formula. They are different. And types of non-stoichiometric defects are as well as follow. Met-Excel defect. Met-Excel defect due to anions vacancies, and KCl shows these types of defect. Centers or the sites from which where ions are missing, and the vacant sites are occupied by the electrons. Next is metal deficiency defect due to cations vacancy. It is due to the absence of metal ion from its lattice sites, and charges is balanced by ions having higher positive charge. They balance the charges. And also classes of solids on the basics of electric conductivity. So conductor, insulator and semiconductor. So conductor's conductivity is 10 to the power 1 to 7 it is, and reason of conductivity is motion of electron, the conductor. And insulator 10 to the power 22, 10 to the power minus 10, it has very low and do not permit the electricity. The reason is they do not permit the electricity. Next is semiconductor 10 to the power minus 6 by minus 10 to the power 4, motion of interstellar electrons or hole or both. There may be motion like this. No, next is semiconductor. So electrons conductors having electrical conductivity in the range of 10 to the power 4 minus 10 to the power 7 lambda centimeter are known as semiconductor. And intrinsic semiconductor, pure substance that are semiconductors are known as intrinsic conductor. And extrinsic conductor, their conductivity is due to the presence of impurities. They are formed by doping. It is defined as addition of impurities to a semiconductor to increase their conductivity. And it also has N type of semiconductivity. Silicon doped with 15 group elements like phosphorus is called as N type of conductivity, and P type of conductivity. Silicon doped with 13 group of elements like gallium is called as P type of semiconductivity. Next, magnetic properties of the solid. So solid can be divided into different classes depending on their response to magnetic field. So diamagnetic field, these are weakly repelled by the magnetic field and do not have any unpaired electrons. So these are weak and do not have any unpaired electrons. And paramagnetic substance, these are attracted by the magnetic field and have unpaired electrons. And ferromagnetic substance, these are attracted by the magnetic fields and show permanent magnetism even in the absence of magnetic field. And antiferromagnetic substance, these substances have net magnetic field, magnetic moment 0 due to compensatory alignment of magnet. And last is ferromagnetic substance, these substances have a net dipole moment due to unequal parallel and anti-parallel alignment of magnetic moment. So this was your chapter solid state. So okay friends, I explained all the topics of this chapter, so I think you understand this chapter. So okay friends, like the video, comment on my video and subscribe my channel bymnCoachingcentre for more video. I will see you in my next video explaining next chapter. Till then, take care, have a nice day, bye.